Hello everyone, welcome to Techionary.com. Let me introduce myself. I'm Janmanchi Krishna. I'm going to teach you about machine learning in the upcoming classes. Let me start with the bang. For anything to start, we have to know what we are going through. Let me tell you what we are going through in this machine learning course. This is what we are going to see: the general definition of machine learning and what is machine learning in formal, you mean textbook definition, and the comparison between traditional programming and machine learning, and the abstract of data mining, because machine learning is rooted from data mining. That is the reason I'm going to give an abstract on data mining, as well as the advancement of data mining, that is need for adaptation of machine learning, is going to be explained. And the significance of machine learning in essence, machine learning in real world applications is going to be explained in the topic. And categories of machine learning has many categories, you can say, and we are going to see each and every category in detail with few algorithms, and you can make your own algorithm after knowing the depth of machine learning. Then algorithm available and mostly used algorithm in the real-time applications. There are some other techniques, other learning techniques apart from machine learning can also be used. Apart from these, there are few more to be added. We'll talk about that later. Let us start. Let's talk in general. What is machine learning? Machine learning is just a branch of artificial intelligence which concerns about the formation or building of systems that can learn from the data. You know, artificial intelligence is a buzzword these days. Artificial intelligence is an umbrella that gives shadow for lot many of technologies over there in the real world. One of those technology is machine learning. Apart from machine learning, there are other techniques are also there, like neural networks, IoT, and lot more. Now our concern is about machine learning. Okay, let us give a small example which makes you very clear that about the difference between machine learning and artificial intelligence. Suppose you have 100 dogs. If you make your mission to know the details of 100 dogs, and when you show the 101th dog, your machine will tell this is a dog of some kind which is among those 100. That is called machine learning. But if you show the cat in place of 101th dog, your machine cannot tell in terms of machine learning. But when it comes to artificial intelligence, it will tell it is not dog but it is something other else. That is a small difference between machine learning and artificial intelligence. Now our goal, what is our goal in machine learning? We have to make some systems, and we have to build some algorithms, we have to build the systems which can take the data and learn from the experience given by the humans. Of course, data is made up of experience experienced by the humans. Let us take 100% data in the general store. How those 100% data is collected? It is just the experience from humans. The experience of humans is tableized or formalized into data. Then those data is fed into our machines, and our machines will do some magical tricks. For other guys it is magical tricks, but for developers you can say it as algorithms. When we crunch the data, we'll get some interesting patterns, we can say interesting dependencies, we can say, or whatever the name you give, but the final result is the useful things are taken or abstracted from the data given by the humans. That is going to happen in our machine learning. Okay, some great people are there for us. You know, every time we refer to something, we have to look back into history. Of course, we don't remember everything, but something is to be remembered. Let us take a couple of definitions from our some of reputed scientists. Machine learning is just this. A computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task T as measured by P improves experience E. I know it is a bit confusing. Let me tell you this definition in detail. Think you are gone into a cricket pitch. Now ongoing you cannot hit like Sehwag because that Sehwag hit due to experience. You are the first player, first ball to play on the ground. Your task is to hit the boundary, and to hit that boundary you need to get some experience. You'll experience 2 or 3 balls, or you can say 1 over as per your dynamics of your play. You take some time to experience the bowler, to experience the pitch, to experience the environment, to experience everything out there. After experience, you will perform yourself, and your performance measure will increase from over to over if you are a good player who takes experience as part of learning. And that experience as part of learning is mentioned as machine learning in this first definition. Now, taking an experience as a mean, increasing the performance in the task is mentioned as machine learning in the first definition. This definition is the first definition what I said about. Now let us talk about second definition. It is a field of study that gives computer the ability to learn without being explicitly programmed. No one will tell you how the ball will swing, whether the right or left, depending on the phase of the ball or depending on the step the ball is going to take. You will decide where the ball is coming and at what speed the ball is coming. There are no one explicitly defining, explicitly saying that okay, the ball is exactly coming with this angle. You just experience the previous balls and previous environment from the pitch, and you're just assuming the ball is coming. That is assuming in human terms, but when it comes to machine we don't explicitly mention okay, we are giving 100 people data, and we are mentioning each and every people's data, like okay, this people data is collected in this environment, this people data is collected in this weekdays. We don't do that at all. We just give the data and we will just say to do that, and our machine will tell us the thing what actually happened. Okay, this is the data collected from this user at weekends, this is the data collected from this user from weekdays, we say. And these slides gives you a clear abstraction of what I said before. If you're not clear with the thing what I said before, let me reconsider this with this slide. This slide tells you about the difference between traditional programming and machine learning. This is traditional programming. In traditional programming, we give some data, we give some programming, we give some structured code, and we feed some data into that program and we'll get some output. Whereas in machine learning, this is a slight modification. We give some data, we give some output, and we'll get the program. Program in a sense an algorithm. An algorithm in a sense will use some data. For suppose you take the data of cricketer itself. We give some data of 5 bowlers. We give some outputs of the best of the bowler, the economy of the bowler, the medians of the bowler, the best wickets of the bowler, and the speed of the bowler. The program in a sense, the performance of the batsman. That is the difference between traditional programming and machine learning. Here comes a small metaphor for you. As I explained before, artificial intelligence and machine learning differs by this. Machine learning focuses on the common categories or common knowledge, whereas artificial intelligence depends on versatile knowledge. Here itself, There are two pictures. No, there are a lot many pictures, but there are two categories of pictures. One is of dogs and one is of cats. When we fed on the left side pictures, when we fed our algorithm with left side pictures, for suppose let us give 4-6 pictures are fed into our algorithm. Our algorithm, in a sense, algorithm for machine learning is fed with these 4-6 pictures. 1, 2, 3, 4, 5, 6. The next time we use these three pictures, our algorithm should be capable of saying these three pictures or belongs to these 6 pictures. In a sense, these 6 picture class is of cat. If you don't know about class and all those, I'm sorry, but I'll tell you a brief of class. Class is nothing but a common template. Like fruit is a class. In fruit class there are mangoes, apples, bananas, etc, etc. Similarly, in cat class also there are many cats. I don't know the breeds of cat, but I guess I know some breeds of dogs. There are some like you can say hutch dog. I don't know its exact name. Okay, lab dog, and some lab dog, labrador. Some dogs are there, right? And similarly, these cats will be also some categories. The common template for class for cat is cat. So 6 are the cats we are feeding into our algorithm, and these 3 are the cats which we are testing our algorithm, and our algorithm should say these 3 also belongs to this 6 cat category. And when it comes to dog, the same thing happens. We feed some randomly 6 dogs. For example, randomly 6 dogs we are feeding our algorithm, and when we show some remaining 3 dogs, it should say yes, this belongs to the dog class. And this is for today's lecture. This is just a brief introduction of machine learning. If you go into deep, it will be quite interesting. You just believe me, trust me, it is a wonderful recipe of present day technology which can be implemented by many programming languages which are being developed, also focusing on the machine learning libraries. For further details, you can mail to techionary.com, and you can ask many questions as possible, and you can give feedbacks on this lecture through mails. Thank you.